Go. Turn around. Okay. So, graphing using intercepts. Right? If it's in standard form, it's very easy. Cover up one term, solve. Cover up the other term, solve. It should go very quickly. Right? You shouldn't find yourself solving to put it in slope-intercept form. So if you get an equation that says graph the equation and it's already in standard form, then that kind of lends itself to very quickly, substitute the y is 0, cover that up. What's left? X equals 4. Right? Cover up the other term. What's left? y equals 4, so y equals 2. So plot those 2 points, draw the line. I mean, we will get to the point where we're graphing things that are in slope-intercept form, right? And you know the y-intercept, and you use the slope to find another point, but there's no point to do that if it's already in standard form. It's just so easy to find the intercepts. So you understand the concept? I mean, you only need 2 points to graph a line, and those are 2 points that are pretty easy to find if the line is in standard form. So I think this is another you try. So try to do the same thing with that one. Except 7, right? Great. If you substitute y as 0, then you get 6x equals 42. Sorry about that. That's messy. 6x equals 42, x equals 7. 7y equals 42, y equals 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Draw a line. How's that? Let's see. The graph crosses the x-axis at 2, 0. The x-intercept is 2. The graph crosses the y-axis at 0, negative 1. The y-intercept is negative 1. So here's you're gonna get a graph, and then you want to find the intercepts. Okay. So I don't think we need to pause for this one. So from this one right here, they identified the x and the y-intercept as 2 and negative 1. 2 and negative 1. Say, what are the intercepts on this graph? So the x-intercept, because it's on the x-axis, is negative 4. The y-intercept, because it's on the y-axis, is 2. So we should be able to look at a graph and identify what do we mean by x and y-intercepts. Too easy. Okay, what's the error in this problem? Is the x-intercept 1 and the y-intercept negative 2? What is it? Andrew. Andrew. What did they do wrong? What is the x-intercept? What do they say? So what does it look like they did? Yeah, they switched them, right? They got the x and the y confused, which is something that happens all the time. So that's the first section, which is graphing a line using the x and y intercepts. The next section is about slope. And you've had slope before, right? So we're all experts in slope? Huh? No. What do you mean by the slope of a line? I mean, qualitatively. You know, what if I ask you about the slope of a road? You know, it's the tilt, right? It's how much is this going up or down? Like if you have a steep hill, then it has a large slope. If you have a really light hill, that's a small slope, right? but it's basically trying to give you some idea of what's the tilt of this line. Okay, and so I wrote it down. It's a tilt or slant or incline or steepness in some way. That's the characteristic we're trying to quantify by this measure of slope. I think, was this our key concept block? I think this was the 235 maybe. So we have we use the lowercase letter m as the letter that represents slope always. Okay, lowercase letter m is slope. So in order to come up with some kind of a quantity which will represent the steepness, we use different ways of saying it. And I know you've heard these before, like slope equals the rise over the run. Okay, the rise means how much is it changing in the vertical. Well, what's the coordinate that we use to state the vertical position of something? The y, right? So when you're saying what is the change in the vertical, you're saying what's the change in y? How much, if I go between these 2 points, how much am I changing up and down, right? And then the run means the change in x. This is the run. I think the run is something that we wouldn't necessarily understand that word in any other except for we know because it's used here. The rise makes perfect sense to us, but we just understand what they mean. Okay, I can accept the run as being the change this way. So we will measure the change in the vertical, the rise, by finding how far it is from this point to this point in the y coordinate only. And then we'll measure the change in the horizontal, right, by finding the change in the x coordinate from this point to this point. Right? And then we will divide. That's what the slope is. That is the formula for slope. Pretty sure that is not a formula that you get on your formula sheet. So you have to know the slope. So it should make sense to us here, right? y2 minus y1, that's this change. x2 minus x1, that's this change. So you need to know that formula to calculate slope. So let's see what's coming up next. So classification of lines by slope, right? The first thing we're going to talk about is just the difference between a positive and a negative slope, right? This is what a positive slope looks like. And you should always think of it from left to right, right? From the left to the right, does it look like it's going up or down? And it looks like it's going up. From left to right, it's going up. That's what we mean by a positive slope. Right? If from left to right, it's going down, that's a negative slope. M is less than 0. These are 2 out of the 4 that we're supposed to know. I like that countdown. So find the slope between 2 points. Right, if you're given 2 points, right, they got x coordinates and they got y coordinates, and we've got a formula which requires those 2. Now this brings up a point that when we did our 9-week test, there was one of the questions that was on that test that is using subscripts like this. I forget, it was like D1, D2, something like that. Do you remember? And I think it caused some issues over what does it mean when you write like Y2 with the 2 down and a little bit to the right, right? That subscript is the designation of this as just being 2 different Y values. It's not like saying Y squared, right? If I use a superscript of a 2, that means something mathematically. This is just a different designation. Just like I could name the students, and I could give a variable or a letter to represent the students in this group right here, A, B, C, D, E. Or I could say, because of students, I could say S1, S2, S3, S4, S5. Use a subscript for that. That's all we mean when we have a subscript like that. So don't get confused about that part of it right there. Okay, so without even looking at the graph really doesn't do anything for us if I know that the points are -4, 2, and 2, 6, right? And a formula is this. So notice that they're plugging in for Y2 and Y1. This is the Y2 is 6, and Y1 is 2. So 6 minus 2. And the X2 and X1, right? X2 is 2, X1 is -4. 2 minus -4. And then that's a simplified. Right? 6 minus 2 is 4. 2 minus -4 is like 2 plus 4, which is 6. Right? Which could be simplified to 2/3. Now, do you have your calculators out? Could you put that in the calculator and see if you could get the same answer? Let's make sure, because if you can't, then we've got some issues with the calculator. We don't want to have issues with the calculator. So how many got 2/3 or 0.666666666? Okay. So here's a couple things to keep in mind, right? How did you enter that in the calculator? Did you use parentheses? Did you first do 6 minus 2? Remember, the calculator now has a way for you to enter it as a fraction, right? You're going to go alpha y equals 1. So watch my up here, alpha y equals, and the first one, n over d, that's numerator over denominator. So you could put it in as a fraction and not have to worry about parentheses, right? So again, this was 6 minus 2 in the numerator, and 2 minus -4 in the denominator, and I hit enter, 2/3. Not only didn't have to use parentheses, it gave me my answer as a fraction. And we'd kind of like to keep our slopes as fractions. Don't turn them into decimals. Because ultimately, we're going to use those to graph. You know, if I have a slope of 2/3, that's going to tell me that from one point on the graph, I'm going to go up 2, right 3. Right? If I have that as 0.66666, it's kind of hard to use that to graph. So try to keep them as fractions. How many of you got 0.66666 like that? So what if I go back to the calculator and I do like you did, right? You probably did parentheses 6 minus 2 divided by parentheses 2 minus -4. Right? And now when I do it, I get this decimal. How do I turn that decimal back into a fraction, since that's the way I want my slope? If you've got that on your screen, hit Math, Enter, Enter. Right? The Math key right here, and now hit Enter twice. And it'll turn it back into a fraction for you. Right? You want to be able to do that for yourself. Like I say, if you entered it as a fraction, it'll keep it as a fraction. But if you didn't, you want to turn it into a fraction, because that's the way we'll graph the line. Right? Okay, so here's going to be a you try. I'm going to do one of them, and then you can do the other two. Right? So I'm going to do number 3. M equals I'm going to use this as my x1, y1, and this is my x2, y2. Do I have to? Do you think it matters which one is x1, y1, and which one is x2, y2? The answer is no. It doesn't matter as long as you're consistent about the way you do the subtraction. I should have said this on the one before. Right? Let's say that instead of this, that I did 2 minus 6 divided by negative 4 minus 2. Then I would get negative 4 over negative 6. And what's a negative over a negative? It's a positive, right? So that's positive 4/6, which is 2/3. Right? So it doesn't matter if I do 6 minus 2 divided by 2 minus negative 4, or 2 minus 6 divided by negative 4 minus 2, as long as I'm consistent, right? Don't do 6 minus 2 in the numerator and then negative 4 minus 2 in the opposite direction in the denominator. Then you're going to be wrong, right? So you can say whichever one is the x1, y1, whichever one is the x2, y2 that you want. So I'm going to do negative 3 minus 5 divided by 1/2 minus 9/2. Negative 3 minus 5, negative 8. What's 1/2 minus 9/2? What's 1 minus 9? Negative 8, right? That's negative 8/2. But what's negative 8/2? It's negative 4. So now we've got negative 8 over negative 4, which is positive 2. So try the other two. See if you can get those. Okay, so in the formula, remember, it's the change in y, which is in the numerator. So I'm going to call this my x2, y2, and this can be my x1, y1. It doesn't matter if you want to do it the opposite. Yeah, I'm looking at you. Please don't. So 2 minus negative 1, because those are y values, right? That's these here. The y coordinate's the second of the pair. The x coordinates are 5 minus 4, right? I went in the same direction. It has to be this minus this divided by this minus this. And now, because I did it in that order, I'm going to get all positives. That'll be 2 minus negative 1 is 3. 5 minus 4 is 1. 3. Right? On the second one, I'm going to call this one my x2, y2. So it'll be m equals 6 minus 3. That's 6 minus 3 divided by 4 minus, that was wrong, 4 minus negative 2, which is 3 over 6, which is 1/2, not 1/3. Okay, well, let's see. What's the only difference between this one and the last one? The slope is negative, right? And can you see that the slope is negative by looking at this line? I mean, what did we say? when it falls from left to right, it should be that you get a negative slope. So given the 2 points, and they are given right there, you put it in the formula, and it better lead to a negative number. If it doesn't lead to a negative number, because you can see the graph, you need to fix something, right? Because it is definitely a negative slope. So let's see, what did they use as their x2, y2? This here? So they did in this order, -1 minus 5, 6 minus 3, right? -1 minus 5 is -6, 6 minus 3 is 3, -6 over 3, -2. So it's a negative slope. So at least if you have a graph, that's an easy check, right? Make sure at least it's got the right positive or negative to it. So try this one. I'm sure that's your turn. Do a slope. Do seats need to move? Too much giggling going on. Okay, now we get to horizontal and vertical lines. Seems like I missed that. No. So these are the two that are going to mess us up all the time. And we kind of already dealt with them in the last section when we were just graphing lines without knowing the concept of slope. But first, we have to keep in mind, that when it's like that, that's horizontal, right? Horizontal is flat. Vertical is straight up and down. So get the right words to this. One of those has a slope of 0, which is fine. That's a number, right? It's right in between positive numbers and negative numbers on a number line is 0, right? And one of these has no slope. And if you think of when they describe the slope of a positive and a negative sloped lines, right? It was, what are they doing from left to right? Well, what would you say about a vertical line? What is it doing from left to right? Is it going from left to right? It's not even going from left to right. So it doesn't even make sense when you use that kind of words to describe it, right? What is this graph doing from left to right? It's doing neither, so it's undefined. It's not going from left to right. Now this one, what is it doing from left to right? Is it going up or is it going down? Neither one, right? It's flat, right? It's like I said, if it was tilted just a little bit like that, it would have a very small positive slope. If it was tilted just a little bit like that, it would have a very small negative slope, right? Now, on a number line, what's right in between very small positive and very small negative numbers? Now, here can be 1 and here can be -1, right? What's the number that's right in between the negatives and the positives? It's 0. It's just a number, right? It doesn't make it undefined. So too much of the time, students will say 0 and then they'll write undefined or no slope. That's not no slope. A slope of 0 is not no slope. The only one which is correctly called no slope is when it's vertical. That's a no slope situation. Now, if you remember, because we graphed these lines already, right? On a horizontal line, every point on it has the same y coordinates. So when I do the y2 minus y1 in the numerator equals 0. And when a fraction has a numerator of 0, then it equals 0. When you have a vertical line, every point on that line has the same x coordinate. So when you do the x2 minus x1, you get 0. Now you're dividing by 0. What happens in your calculator if you try to do like they've got here, -4 divided by 0? Try it. What's -4 divided by 0 in your calculator? It's an error, right? Because you're not allowed to do that. Now, if you try to do 0 over 6, what do you get? You get 0, and 0 is a number, right? There's no problem with that. So just try not to confuse the no slope situation, undefined, of a vertical line with the slope is 0. Just a number. So try to find the slope of those two. My guess is that one of them is vertical and one of them is horizontal. So which one is the vertical line, 4 or 5? The vertical line has a divide by 0 in it, which means no slope, right? The horizontal line has a numerator of 0, which means the slope is 0. It's flat. It's not positive, it's not negative, it's right in the middle, which is fine. So this is undefined vertical. Right, this is 0 horizontal. So a line with a slope of 0 is horizontal, and a line with an undefined slope is vertical. I think we got that point across. What's the error? They're using these 2 points, 5, 3, and 2, 6. What did they do wrong? Chantry. Okay, did the subtraction in one direction in the numerator, the opposite direction in the denominator, right? So it should have been, if it's going to be 6 minus 3 in the numerator, it's got to be 2 minus 5 in the denominator. Got to do it in the same order, right? What's the, I think there's one more like that. Okay, what's the mistake here? You can see the points that are there. They've got 12 minus 6 in the numerator. What's wrong with that? Yeah, they got the x's in the numerator, right? Should have been the other way around. So there's the homework.